If you want to understand the transformations of functions by reflections, you don't need to consider what the original fx looks like. You just need to focus on the relationship between the transformed function and the original function. Here, as you can see, this is the transformed function, transformed function, transformed function. So, for the three situations, the original function is fx. So, you don't need to consider the graph of this function. You can assume any graph representing the original function. For example, we can assume this is the original function that you say fx. Now, if you want to figure out today's function's graph on the basis of the original function, you just need to guarantee the y-coordinate does not change. That you say, on the new graph, the y value should be the same with the original function. The change should happen in the x coordinate. So this x, its opposite value should be negative x. Here, if this is the original x0, in this function, negative x should be negative x0. So its corresponding point should be here. Next, if for this one, if this is the new x0, the corresponding negative x0 should be here. But for this x0, the y-coordinate should be fx0. Here, it should be fx0. So on the new graph of this function, the y value should be same with this number. So the corresponding point should be here if the x value equals negative x0. Similarly, for this point, the corresponding point should be here. This is the same y value, so this is the image point for this point on the original function. We can locate this point here. It should be negative x0. So similarly, we can locate the corresponding point. Then we connect every point one by one. We can get the new function that you say f negative x. This is the transformed function of the original function. This is the original function. We call this reflection of the original function. Okay, now let's move on to next situation. For this situation, negative fx. From the expression, you will find out the original function still fx. We still assume the original function, the image, the graph is the same. But this time, the new function is just the opposite value of the original function. It's not the x value's opposite value. It should be the opposite value of the original function. So on this new function, this x should be the same with this x, but this negative, meaning this function's values, opposite values. So the x coordinate should be the same. The y coordinate should be the opposite number of this function. So we can figure out for this point, its image point should be here. Okay, it should be here. That you say here it should be negative fx0. For this x0, the x coordinate should be the same but this time the y coordinate should be this fx0's opposite value for this one and for this one. So if you can locate several points on the new function, you can connect them one by one, then you can get this negative fx. This is the new transformed function on the basis of the original function. We also say it's the reflection of the original function, but this time, this reflection is over x-axis. But last time, the reflection is over y-axis. It is f negative x. Okay. After analyzing these two transformed functions, let's move on to this situation. That you say, you need to compare this expression with this expression. That you say, first step, you need to guarantee this x value should be the opposite value of this x coordinate. On the basis of this situation, that you say, for this part, you need to follow the change of this first situation. That you say, on the basis of this original function f(x), this part, this transformation should be like this. Then, on the basis of this function, you need to take the opposite value of this function. That you say, for the same x coordinate, you need to take the opposite value of this value. So, for every point on this function's graph, you need to guarantee the x coordinate the same, but the y value should be the opposite value of this value. It should be here. Okay, so every point, you can locate the corresponding point on the transformed function's graph. Then you need to connect the corresponding point. So it should be like this. Every point, the image point is here. So here, it is the transformed function's graph. It should be negative f, negative x. Okay, so this transformed function should be the reflection of this function's graph in x-axis. This function's graph should be the reflection of this original function in the y-axis. Okay, this is the relationship between this original function f negative x, negative fx, and negative f negative x.